Hey guys, sorry I cut off the first half at a bit of a weird spot. We were right here trying to figure out what on earth this integral is. And so, just a brief recap, this integral is part of the larger problem of figuring out what mu is, because mu is going to be e to the exponent of this integral up here, right? And so first thing we need to figure out is what on earth that integral is. And I'm telling you, it comes out to ln of the absolute value of x. Don't worry too much about that right now, because we haven't talked about logarithms and we haven't talked about natural logarithms. So one, you don't know how this integral gives you that. And two, what you don't know is that, so we're saying that this is what that integral equals, right? So that means our next step is to write mu is equal to e to the ln of the absolute value of x, all right? So the way this is going to work, it seems a little bit wishy-washy, but it's easier this way. Again, if you guys want, put a comment or send an email and I can make a separate video explaining why these things are the way they are. But turns out that e and this little ln guy are opposites. So it's like multiplication and division or addition and subtraction. They're opposites. All right, so if you have e here and then you have ln in the exponent, ln of something in the exponent, then what you actually can do is it really simplifies your lives if you, what on earth is that? If you learn this trick that e to the ln of anything, the e and the ln bit cancel, and you can also throw away the absolute value sign. And so what you're left with is just x. So that's why it gets cleaned up, and that's why I took this example out of my notes, is because I know we haven't covered this becoming that, and I know we haven't covered this cancellation between e and ln, but right away it's been cleaned up. All right? Right away it's been cleaned up. And so now we know that mu of x is just x, right? So that's what we know about mu. I'm just going to throw up the equation one more time. We had y prime plus 1 over x times y is equal to x. So this right here was our q of x. This right here was our g of x. And now we also know mu of x is equal to x, right? And so I'm going to turn off the light because we're up there. So y prime plus 1 over x times y equals x. That's what we had in the original question. We know that from our standard form of linear DE that this 1 over x bit is q of x, and this x over here is g of x. And we also just calculated a minute ago that mu of x is also x. So g of x is equal to x, and mu of x is equal to x, and q of x is equal to 1 over x. Now our next step after mu, this hopefully you guys remember, but if not, that's why we're doing review. I'm going to move it over a little bit. Y is equal to 1 over mu of x times the integral of mu of x, g of x, dx, and then we're throwing in the plus c so that we don't forget about it later. All right, so that's the formula that we have to work with now. All right, and it does look intimidating at the start, as it always does. There's a lot of functions being thrown into an integral, and it's all being multiplied together, and it's kind of weird, but it'll really simplify itself in just a moment, because we have y is equal to 1 over, we know mu of x is equal to just x, right? Open bracket, And then the integral, mu of x, again, we know it's just x, and g of x is also x, dx plus c, right? Now, we can simplify this a little bit. X times x is just x squared, right? So, we can use that in its simplified form of just x squared, and we can go from there. The integral of x squared, hopefully you guys will remember, the rule is increase the exponent by 1 and then decrease, and then divide by the new exponent, right? So we have x squared, so if we want to increase the exponent, so this is just this integral right here. We increase the exponent from 2 to 3, and then we divide the whole thing by that new exponent of 3, right? So this is the answer to this integral up here. All right, so the integral of x squared dx is equal to x cubed over 3, or if it helps you visualize the answer better, 1/3 or 1 over 3 x cubed. So that's what the integral evaluates to. All right, and so we can actually just throw this up here. So we get 1 over 3 x cubed, and then we just don't want to forget about the plus c at the end. And here might be the example where you guys finally see why I've been writing the plus c with the integral this whole time. Our next line is going to involve kind of throwing all of that stuff together. So if we do distributive property, we'll multiply this whole thing into this term right here, and then we'll also multiply it into that term over there, which is just the c, and then add them together. So our next line becomes 1 over x times 1 over 3x cubed plus 1 over x times c, right? Now if you look over here, x cubed and x. The x cubed is in the numerator. It's technically x cubed over 3. Maybe it'll be easier if I write it this way for now, x cubed over 3. You can cancel out one of the x's here, because it's technically x times x divided by x over here, right? So you can cancel out this x with one of those, and it becomes x squared on top. And then you just have this fraction of 1/3 left over. So you're left with 1/3 x squared plus c over x, because that's just doing the multiplication. You're left with this fraction. Now if you want, you could, I guess, state a new arbitrary constant that's equal to 1 over x times c, but that's kind of, it's kind of confusing to throw that in. So just leave it in this form. It would get you full marks on a test. Definitely it would get you full marks on a test I give, for sure. And so this would be your final answer. Fairly straightforward, I think, I hope, at this point. But if not, that's okay. Go back a lesson or two ago and review the process to get through this. What I'll do now is I'll just write down the whole process one last time, and that will be the end of the review for how to solve a first order linear DE. I'll probably make the test just solving 2, maybe 3 of these DEs, or maybe 2 this way and then one that you just kind of think about, like we did at the start with the e to the t or e to the x or sine or cosine, stuff like that. So we'll see. I probably won't chuck that kind of stuff at you because it'll be like a you know it or you don't know it. So I'll probably just make it something like this. But it'll be kind of like an open book test. You guys will be allowed to go back and watch the YouTube videos if you need to, just bearing in mind that you're going to have limited time to finish, right? So in that sense, it won't be open book, but you guys are welcome to talk to one another and just submit one answer sheet to Miss Fiona, I guess, or Mr. Austin. And so what I'll do one last time is I'll write out how to solve a first order linear DE in standard form. So this is really the only thing you're going to need to know for your quiz, test, discussion thingy on DEs, all right? And whatever mark you get on it, don't stress about it. It's just to see how well you guys understand it. I just wanted you guys to see this before you go on to more advanced schooling. So this is pretty advanced stuff, so I'm really happy if you guys get it, but if you guys don't, that's fine. You can take another crack at it next year or in a couple years' time, and you can always come back to these videos and see if you understand it down the road, if you think you understand it now. So what we'll do right now is we'll write down a DE in standard form, so that's y prime plus, whoops, I've been using the wrong variable, q of x times y is equal to g of x, all right? Where q of x is the same thing as big Q divided by big P, because remember we used to have that big P here, big Q, and big G over there, right? And then we divided everything by big P, right? And this is what we're left with. This is the standard form of a first order linear DE, all right? And so the first thing you need to do, step 1, calculate mu of x, which is equal to e to the integral of q of x dx. And yeah, you can ignore the plus c from that step. So that's what you need to find. This is mu. That's mu right there. So that's what you need to find first, is mu of x, which is equal to e to the integral of q of x dx. All right, once you've found mu, your next step is to just solve for y. Remember, the goal of these DE questions is to solve for y. So we'll do that next. And the way you do it is y is equal to 1 over mu of x times, open bracket, the integral of mu of x g of x dx plus c. Apologies for the brackets, I'm sitting very right next to the whiteboard, so reaching over there and seeing if it looks good is a bit of a struggle. But hopefully you guys can read that. Hopefully you guys can make sense of the brackets and of the formulas. So that's the second thing that you need to find. So after you find mu, you plug mu into that second formula down there, and that's all you need to do. You plug in the stuff, solve this integral, and you're done, pretty much. We'll figure out how exactly we're going to do the test. What I'm thinking right now is I'll send a video of the probably just 2 questions, just for you guys to work on as a group. Maybe 3 if you're feeling like giving the extra one a try. It'll be bonus. I always give you guys bonus, right? So I'll make a 3rd one maybe for bonus, and you guys can work on it all together, and then maybe give your answers to Miss Fiona, and she can send me a picture, or Mr. Austin, and he can send me a picture, and then I'll look it over and find some way to get your grade back to you guys collectively. All right, so hopefully you guys don't have any questions at this point. If you happen to get to this video at the not at the end of a class, but in the middle of a class, and the only next thing for you guys to go to is the test, what I would say is use the rest of this class, however much time you might have, as review of your own notes. You guys can talk together, maybe go back through the other videos, but try and do some review because this stuff does get complicated really fast, I know. So try and go through the older videos, go through this video again, see if you can work through the problem that we just did, start to finish by yourselves. If you guys are within the first like 5 minutes of class that you happen to finish this, then I'd say start the test. I'll probably make that in the next day or two. I might make it tonight, but we'll see. But yeah, good luck, and hopefully you guys understand everything. If you don't, send me an email. See you guys.